Okay, I'm going to go ahead and show you how to solve a square root equation. We're going to work quite a bit with these in class, so you get plenty of practice with them. As we go through this, you're going to have, after you get the answer, you're going to have to actually check your answer to see if it's an actual answer or what we call an extraneous solution. So let's go ahead and work this problem right here. We have the square root of 3x minus 11, and that's going to equal x minus 3. Okay, so not the simplest of problems to solve, but it's not terribly bad. The first thing we're going to do is we're going to square both sides to get rid of the square root. So this leaves me with 3x minus 11 equals x minus 3 squared. Now you're going to have to FOIL this. I'll show you in class how to FOIL and use the box method. I'm going to just do this real quick. So we have 3x minus 11. This is going to be x squared minus 6x plus 9. And then we're going to have to basically move everything over, get it set equal to 0, and then solve. So at this point, we're just solving a quadratic, which we just finished. So I'm going to subtract 3x and add 11 to both sides. So I'm going to subtract 3x and add 11 to both sides. So I'm going to get 0 equals x squared minus 9x plus 20. Now you can use the AC method of factoring. You can use Dr. Lowe's method if you wanted to, or even the quadratic formula. I'm just going to factor this. I'm not going to show every single step. This is going to end up factoring to x minus 5 times x minus 4, simply because negative 5 and negative 4 gives me my negative 9 for the negative 9x, and negative 5 times negative 4 gives me a positive 20. At a certain point, you shouldn't have to do every single step to factor. You should be able to do it fairly quickly. We've been doing this quite a bit now. Now we're going to use our zero product property, and we're going to say that x minus 5 equals 0, and then x minus 4 equals 0. We're going to solve both of these, and we're going to see that x actually equals 4 and 5. Now, we're not done here. We actually have to check, because one of these may actually be an extraneous solution. We don't know until we actually check. So what we do is we take each number, we plug it back into the original problem, and look for a true statement. So let's try 4. So we're going to do 3 times 4 minus 11, and that should equal, when I take the square root of it, that should equal 4 minus 3. Well, 4 times 3 is 12, so I have 12 minus 11. We're going to take the square root of that, and that's got to equal 1 for it to actually be a solution. In this case, 12 minus 11 is the square root of 1 equals 1, which gives me 1 equals 1. So 4 actually works. So 4 is an actual solution to this problem. Now we need to check 5. So we're going to plug 5 back in. We're going to do 3 times 5 minus 11. Of course, we have to take the square root of it, and that's got to equal 5 minus 3. Well, 5 times 3 is 15. Minus 11, of course, we're going to take the square root of it, and that should equal 5 minus 3, which is just simply 2. 15 minus 11 is 4. We're going to take the square root of 4 equals 2. And at this point, I don't really care if you finish it off. You should be able to see that the square root of 4 is going to be 2, which equals 2. So this is also a solution. So both of these, 4 and 5, is a solution to the equation, the square root of 3x minus 11 equals x minus 3.